NASA is hiding the real truth about the sun's core. Klaxons bite through the control room as the CME density trace vaults off scale. That spike wasn't in any model, someone says, too calm to be okay. Parker's feed jitters, magnetic vectors flip, then flip again, clean 180s like a cracked whip. Another voice flat, if this couples to the current sheet, grids are in play. Then the line I can't shake. They said the sun was steady. It is. We were taught a smooth furnace at the center and a gentle conveyor to space. But the closer Parker flew, the more the story fractured, bursts, packets, rhythms. If you want to know why that matters, we need to rewind. The official story, built to break. Here's the version we grew up with, the one that made stars feel solved. Gravity squeezes hydrogen in the core until protons fuse. The proton-proton chain turns a sliver of mass into energy. Neutrinos slip out instantly. Photons random walk through the radiative zone for ages. Past that, convection takes over, hot plasma up, cool plasma down, until energy reaches the photosphere where we see granules, sunspots, and loops. Hydrostatic equilibrium keeps the whole thing balanced for billions of years. A steady furnace, a steady outflow. Simple, comforting. Helioseismology gave that picture muscle. Sound waves ring through the sun. We read the surface oscillations, reconstruct the interior sound speed profile, and it looks smooth. The Tachocline, the shear layer between the radiative and convective zones, shows up razor-thin. Rotation maps make sense. Differential spin in the envelope, near solid in the interior. Meanwhile, the great neutrino headache from the 196s becomes a triumph in the 200s. Detectors finally count the missing particles once you allow for flavor change. The fluxes line up with models. Crisis over. Confidence surges. On paper, the corona had a plan too. Either countless tiny reconnection events, nanoflares, release heat in bursts too small to notice from afar, or waves ferry energy upward to dissipate as heat. Likely both. SOHO, SDO, Hinode stack evidence for braiding, outflows, and wave modes. Add enough small events and efficient damping, and the million-degree paradox feels payable. The job of the Parker Solar Probe is to fly into the corona and settle the ledger. Find the heating, map the outflow, and nail down how the wind accelerates. But the "it all adds up" promise carries a catch. Even before Parker, estimates in some quiet regions suggested the budget didn't close unless you pushed event rates and wave amplitudes to the edge of plausibility. Opacity tables and composition tweaks could rescue helioseismic fits, yes, but that sensitivity hints the knobs matter more than we like to admit. When small tensions move big numbers, you pay attention. Then Parker gets close, and the wind stops behaving like a hose. Instead of a laminar stream that gets cleaner near its source, instruments see magnetic switchbacks, S-shaped reversals where the field flips 180 degrees for seconds to minutes, then snaps back. Plasma speeds kick during the flips, temperatures bump, and the signatures look Openness. Correlated changes in field and flow like waves with teeth. The wind isn't a single tone. It's riffs and bursts, stitched into patches with preferred spacings. And those patches repeat enough that cadence becomes a word you say out loud. Here's where the official story starts to creak. Hydrostatic equilibrium still holds. Fusion in the core still rules. The average star still matches the average model. But the edges, the parts that decide hazard, don't act average. If energy leaves in packets, not a pore, then the last mile is a rhythm, not a pipe. Space weather stops being background noise and starts being a schedule. Meanwhile, one discovery sneaks in with quiet force. Parker crosses the Openness critical surface, the boundary where the wind decouples from the sun's magnetic grip, and finds it wrinkled, not spherical. The solar wind still co-rotates farther out and faster than standard models predicted, order of magnitude faster in places. That matters. If rotation stays coupled longer, CME trajectories bend more than we budgeted, and age estimates based on stellar spin-down need a second look. Not a rewrite, an asterisk with sharp edges. And then the heat itself. Parker flies through bursty heating, temperature anisotropies that swell inside switchback clusters and relax between them. Waves carry energy efficiently, but dissipation is patchy. Reconnection dumps heat in pulses, but rates wobble across regions. Dust, of all things, shows up as a small, real knob near perihelion. Charge exchange and nanograins adding background heat and complicating diagnostics. Subtract the grit and the packeted structure remains. The official model survives as a baseline. It has to. But baselines are maps, not terrain. Up close, you see ridges and ravines we couldn't draw from Earth, and those features rhyme with soft spots inside. Helioseismic residuals near the Tachocline that don't vanish no matter how you tune opacities. Rotation shear that carries texture with latitude and time, and neutrino spectra that are officially steady, yet precise enough to dare future searches for breath-sized wobbles. Nothing here screams broken star. Everything whispers non-uniform delivery. Why should you care? Because packets and schedules are what knock power out on a Thursday and keep it out through Monday. Because satellites don't fail on averages, they fail on clusters. Because astronauts live by timing, and timing is a drumbeat, not a line. The official story got us to the doorstep. Parker opened the door. Now the room looks lived in, and there's a metronome ticking somewhere we can't see yet. The first fracture, switchbacks and spikes. 3 days after Parker skimmed the Openness critical surface, the plots looked like a lie detector gone feral. The magnetic field vector didn't just wiggle, it flipped hard, clean 180s, then flipped back over seconds to minutes. The team started calling them switchbacks. They weren't rare, they were everywhere. Stakes first. If the solar wind is built from kinks, not a smooth stream, energy isn't leaving the sun like a faucet, it's snapping like a whip. That kind of intermittent acceleration turns space weather from a background hiss into sharp notes you can't ignore. Operators care about notes. Notes stack. What actually happened was painfully clear in Parker's instruments. Field saw the direction of the magnetic field reverse by tens to hundreds of degrees, while SWEAP watched the plasma speed spike during the flips. The changes were Openness, field and flow rising and falling together, so not random gusts but coherent structures carrying wave energy. Inside a switchback, the field could briefly point sunward while the plasma still streamed outward. It's like your compass spun, insisted you were driving east, and your car just kept roaring west. Impact landed immediately at 2 scales. Locally, each flip kicked the wind and nudged the proton temperature, hotter along the field than across it. Globally, when you add up thousands of these kinks, they start to look like an engine. Magnetic stress unwinding into kinetic energy, accelerating and heating the wind in pulses. The solar wind's bulk speed and heat become emergent properties of a million tiny whips. Meanwhile, something else showed up in the cadence. Switchbacks arrived in clusters, patches where flips came in trains with near-regular spacing. Not clockwork, but not white noise either. In those patches, proton distribution sometimes split into 2 beams, one fast, one faster, then merged. That's a jet signature nested inside a flip. The rhythm implied a loading mechanism that didn't just drip energy, it cued it. Stakes again. Rhythm means schedule. If the sun's field is being wound and released on preferred timescales, then predictability isn't about averages, it's about catching the bars between beats. Miss the beat, miss the hazard. Where do the flips come from? 2 camps went to work. One pointed at interchange reconnection near coronal hole boundaries, closed loops snapping and retying onto open field lines, leaving folded field and a jet. The other argued for nonlinear Openness waves steepening into switchbacks as they propagate. No topology change required, just wave physics turning smooth oscillations into kinks. Parker returned evidence that refused to pick a single winner. Reconnection exhausts with classic signatures here, wave-like phase relationships there. The sun didn't care about our categories. It used both. Microstory. On one perihelion, an engineer watching live plots typed, "Are we inside a braid?" The reply came back, "We are inside a lot of braids." 20 minutes later, SWEAP caught the 2-beam distribution, then watched it heal. In the next review, someone circled that minute and wrote, "Flip plus jet." The note stuck. Impact spread downstream. In alignment windows, Solar Orbiter saw the sharpest switchbacks near the sun mellow into broad microstreams farther out, like tight curls relaxing into waves as they traveled. Spectra flattened, angles eased, and the wind picked up speed. That's energy transfer you can trace. Tension unwinds, motion rises. Not a model, measurements. But one problem kept biting: the rate. Quiet sun passes, regions that should be the cleanest wind factories, still hosted dense patches of flips. If switchbacks were only surface braids leaking upward, you wouldn't expect that many, that strong, that deep inside coronal holes. Yet Parker flew through hours where the waiting time between flips clustered around a few minutes, then drifted, then came back. A drummer with a loose wrist, not a metronome. Meanwhile, Parker picked up occasional backstreaming ions, particles moving opposite the dominant flow. Brief, rare, but real. Energy wasn't only pouring outward. Some was reflecting, refracting, and reprocessing. That kind of ping-pong boosts local heating without flares you can point at, and it matters for the coronal ledger you balance at the centimeter scale. Here's where the fracture widens. If switchbacks are ubiquitous and rhythmic, then acceleration and heating are last-mile add-ons. They're stitched into the wind's fabric from the start. Treat them as refinements, and you undercount the very mechanism that sets the wind's personality. Treat them as drivers, and the rest of the physics starts to line up. Bursty heat, packeted outflow, microstreams downstream. Language tried to keep pace. Early preprints called switchbacks ubiquitous. Journals softened to prevalent. Some abstracts risked consistent with acceleration. Reviewers preferred associated with. The plots didn't change. The verbs did. Microstory pressure version. A postdoc titled a draft switchbacks as wind engines. Her mentor crossed it out and wrote switchbacks and wind acceleration. The data stayed. The implication went quiet. She got the talk slot. What nobody wanted to say yet hung in the air after group meetings. Switchback patches sometimes echoed across passes months apart after you corrected for orbit and rotation. Not the same structures, but the same preferred spacing showing up in different places. Tie that to subtle helioseismic hints that shear at the Tachocline isn't uniform and may pulse with the cycle, and you get a thought that makes funding committees twitch. The rhythms above might be sinking to rhythms below. Stakes sharpen here. If the wind's acceleration and heat arrive on schedules set by a deeper clock, then the hazard isn't just how big is the next CME. It's, will the next CME ride a switchback train? That pairing is what turns a day's storm into a week's. We can argue sources. We can debate wave steepening versus reconnection footprints, but switches flipping in trains are the first fracture in the tidy story. The sun didn't send Parker a smooth hose. It sent a braided whip with a beat. And once you hear the beat, it's hard to unhear it. The corona's impossible heat. To understand why those flips rattled nerves, sit with the oldest wrong-feeling fact in solar physics. The photosphere sits near 5,800 Kelvin. A few hundred kilometers above it, the corona soars to millions. Heat isn't supposed to climb that hill. For decades, we called it a paradox and promised the details would add up. Parker flew into the details and found heat that arrives like weather, not climate. The ground truth came as the probe slid through lanes that looked calm from Earth. SWEAP watched proton temperatures spike in short bursts, hotter along magnetic field lines than across them. FIELDS logged sharp Openness signatures alongside those spikes, kinks that carried energy in, then relaxed. Electrons flared non-Maxwellian wings, a tell that energy arrived faster than collisions could smooth it. And when the switchbacks came in dense patches, the heat rose and fell in step. Heat wasn't background, it was timed. Stakes first. Bursty heat changes the way risk lives. Satellites don't fail on averages. They fail when charging layers build fast and discharge hard. Astronauts don't get dose from the mean. They get it when energetic particles arrive in swarms. Grid transformers don't burn out in textbooks. They run hot through clustered days and die on a Tuesday. Packeted heating moves all of those odds. What actually happened during those intervals looked like a machine with gears. Parker crossed skinny current sheets, places where the field changes sharply, and saw temperature anisotropy swell, then relax over tens of seconds to minutes. In some intervals, the proton distribution split into core plus beam, a fast tail that matched short jets in the field data. Elsewhere, the spectra showed turbulence cascading energy to smaller scales, where it could finally thermalize. Wave transport did the hauling, reconnection and turbulence did the unloading. The division of labor changed block by block. Then came a finding that turned a knob into a lever, a helicity barrier. In regions where magnetic pressure dwarfed plasma pressure, fields strong, gas light, turbulent energy didn't smear into uniform warmth. It reflected and redirected, funneling preferentially into ions. Protons heated far more than electrons, sometimes by an order of magnitude, like a filter choosing who gets cooked. That selectivity explains why the corona can bake without the same heat showing up in the electron channel. It also means small injections of energy can produce big ion temperatures if the magnetic geometry is right. You don't need a bonfire, you need the right wind. Impact of that barrier ripples outward. Preferential ion heating changes sound speeds, wave speeds, and how quickly energy can move, all of which feed back into how switchbacks evolve and how the wind accelerates. It also paves a path to explain why the corona can roast while the surface looks tame. The filter sits above the stove. You can turn the flame modestly and still scorch the pan. Meanwhile, dust complicated and clarified at once. Near perihelion, Parker detected enhanced pickup ions and tiny plasma blooms from nanograins shattered at high speed. Those interactions add a trickle of background heat and tilt some diagnostics. But when the probe skimmed the edge of a dust-poor cavity, the gritty term faded and the cadence stayed. Subtract the sawdust, the drumbeat remains. Stakes again, this time in dollars. In May 2024, a run of space weather stretched over days as CMEs stacked and high-speed streams joined. Auroras reached latitudes that don't buy snow tires. Precision agriculture across the Midwest lost GPS reliability at the wrong hour. Planting depth and spacing wandered. The estimate ran to hundreds of millions. Operators who planned for a single hit watched a sequence instead. Packeted heating and pulsed acceleration are the physics underneath that kind of weak. A quiet thread kept tugging from below. If heat rides a schedule tied to switchbacks, and switchbacks sometimes echo across rotations, then the source isn't just coronal footprint chaos. Helioseismic inversions still carry that sliver of residual near the Tachocline, small, persistent. Rotation shear shows texture that shifts with latitude and phase. You don't need the core to lurch. You need the delivery system to gate, opening and closing on preferred timescales. That's enough to imprint a beat on the blanket. Micro story. A thermal engineer on a satellite program started watching Parker's public cadence index like weather. On days when the index jumped, their charging alarm spiked hours later, then calmed, then spiked again. He printed a week of plots, taped them to his cube, and wrote "Heat has a schedule" across the top. He didn't wait for a paper. He added a clustering term to a RISC script and sent it to ops. Language tried to sand this down. Early drafts wrote Bursty heating challenges homogeneous models. Final versions wrote refines. Press releases said new insight, then quietly admitted energy budget tensions remain. The tensions matter. In some quiet lanes, even generous counts of nanoflares and wave damping underpay the bill unless you accept schedules and filters. The barrier, the bursts, the anisotropy, they're not side stories. They're the ledger entries that balance what we actually measured. Here's the hinge. If the corona heats in packets filtered by strong fields and those packets arrive with the rhythm of switchbacks, then the hazard lives where the physics breathes. You forecast clusters, not just peaks. You pick launch windows not by index alone, but by beat. And you stop telling yourself that heat moves like syrup. Up close, it snaps. Helioseismology's soft spots. To follow the beat inward, You stop watching light and start listening to sound. The sun rings. Millions of pressure modes drum through its body, and we read the ripples on the surface like an EKG. For years, that EKG looked clean enough to frame. Then we stared longer, tuned finer, and a few murmurs refused to go away. Stakes first. If our interior diagnosis rests on sound, then persistent misfits in the sound speed profile aren't decoration, they're structure. Those slivers tell us where temperature, composition, or transport differ from the tidy profile in textbooks. And that matters because those gradients decide how the dynamo shears, how magnetic bundles form, and which rhythms can climb to the corona to become the packets Parker met. What actually shows up begins near the tachocline, the narrow shear layer between the radiative interior and the convective envelope. Inversions of P-mode frequencies, turning surface oscillations back into internal sound speed, match the standard model over most depths. But close to about 0.7 solar radii, residuals persist. Change opacity tables, update heavy element abundances, tweak the equation of state. The residuals shrink, not vanish. Different teams smooth them with different regularization choices and still leave a sliver. It's the kind of leftover that makes careful people uncomfortable, then determined. Meanwhile, rotation maps reveal the other soft spot. The shear isn't a razor, it has texture. The convective zone spins faster at the equator than the poles. The radiative interior is nearly solid body. The transition's thickness changes with latitude by a little, and some analyses hint that thickness and local shear strength breathe with the 11-year cycle. Not wildly, subtly. Enough that if you're mapping where magnetic field is forged, you draw bands, not a perfect circle. Impact lands in model space. You can fit helioseismic data with either slightly higher opacities or slightly different metallicity. Both routes buy you a match. Neither is uniquely demanded, and both push consequences elsewhere. That degeneracy, composition versus opacity, isn't a scandal. It's a sign the sun lets us trade one uncertainty for another without triggering sirens. But it also means a real, structured deviation could hide under choices we call reasonable. The neutrinos walk back into the room as the one messenger from the core we can't mute. After oscillations solve the headline deficit, detectors like Super K, SNO, and Borexino measured fluxes consistent with a standard-like core. Zoom in, and you find edges. The 8B flux sits within a few percent of high and low metallicity models, but the error bars still overlap both benches. Borexino's CNO detection, precious and hard one, prefers higher metallicity at face value, yet systematics keep a careful, consistent within the sentence. Time series searches for rotation-tied modulation, peaks near 27 days, find hints that fade when you change cuts. The official verdict holds, no statistically significant periodicity. The physical itch remains because 0.1% wobble at the source would look sub% at the detector, and would matter if it lined up with Parker's cadence windows. Microstory. A seismology team puts a residual map on the wall, a thin seam of misfit near the tachocline thicker at mid-latitudes. Someone says it's an opacity artifact. Someone else says, then why does it drift with phase? The room doesn't vote. They schedule a run during the next Parker perihelion and write coincident in the margin. Meanwhile, gravity modes, the G modes that would cut straight to the deep interior, stay frustratingly shy. Claimed detections arrive, wobble in confidence and recede. Without them, the core's rotation rate and fine temperature structure remain inferenced by proxy. That privacy buys the core time to keep its secrets and leaves our pulse-staking focused on the shear layer where the dynamo actually grinds. Action in the analysis room shifts to letting latitude and time breathe. Instead of a single tachocline thickness, maps begin to show ridges and valleys, slightly thicker here, slightly thinner there, evolving over months. During windows when Parker reports strong switchback cadence, a few inversions show shear bands that subtly sharpen. It's not proof, it's rhyme. Enough to justify more aligned campaigns. Parker's cadence, solar orbiters' footprints, high-cadence magnetograms, and targeted inversions, all on the same calendar. Impact for viewers is direct. If shear bands shift on weekly to monthly scales, then the magnetic bundles that rise along those bands are gated by a clock that isn't just the 11-year chorus. That clock seeds where open field lines form, which decides how CMEs thread through space, which decides whether a storm glances off or threads the needle. Your satellite drag budget, your grid's hot week, a crew's safest launch day, those are helioseismic questions wearing different badges. Language tries to stay calm. Papers say latitude-dependent tachocline structure instead of bands with a beat. They note tensions remain near 0.7 R instead of residuals that won't die. Reviewers ask for surface term corrections, and authors oblige. The soft spots survive every correction. They live where the rhythm would live if the sun's delivery system were gating energy in packets. Here's the hinge you can test without hype. Pre-register a neutrino search for sub% modulation during Parker's strongest cadence runs. Publish helioseismic asymmetry maps with weekly cadence during the same windows. If nothing moves in either channel, the beat lives above. If shear maps breathe and neutrinos stay flat, the clock sits between Tachocline and corona. If both twitch in step, the whisper from the heart cleared the noise. Because the sun's song reaches us in different voices, Parker hears the drum on the skin. Helioseismology hears the wood resonate. Neutrinos hear the hands. If those voices ever line up on a bar line, the soft spots become a score. The patchwork sun, clump power, not a smooth core. Follow the rhythm outward and it pulls you toward a thought textbook's dodge. What if the sun's engine doesn't deliver power like a single blue flame, but through neighborhoods, zones that flare, fade, and hand off? Not fantasy, an inference from what Parker actually crossed. The wind left in packets, the corona heated in bursts, switchbacks clustered with preferred spacings. Push that logic down one layer and a patchwork emerges. Stakes first. A patchwork engine changes the risks we plan for. Satellites survive averages, they fail on clusters. Grids ride through single hits, they sag across sequences. Astronauts don't fear quiet backgrounds, they fear the hour the drummer speeds up. If the sun's delivery is clumpy, then hazard isn't a number, it's a schedule. What actually showed up were echoes across heights. Near the sun, Parker recorded switchback trains, flip, breathe, flip, waiting times that clustered around a few minutes and drifted with position. Farther out, solar orbiters saw microstreams that wore the same cadence after time of flight. In EUV movies, coronal lanes brightened in bursts that matched the packet rhythm overhead. The pieces lined up like a supply chain built from pallets, not a conveyor. Now nobody has instruments in the core. This is inference, not intrusion, but the chain has links you can trace. Start at the surface. Footpoints at coronal hole boundaries and ephemeral region rims jitter with small, quasi-periodic motions. Those are the doors interchange reconnection uses. Above them, Parker's braids snap into switchbacks. Between the sun and 1 AU, microstreams carry the same beat. Meanwhile, helioseismic maps hint that the Tachocline's shear bands carry texture that shifts with phase, slightly thicker here, sharper there, on timescales of weeks to months. If the shear band is the forge, those shifts gate how and where magnetic bundles rise. Gating is the polite word for clumping. Impact lands in the tails of every distribution that matters. Keep the same average luminosity and you can still fatten the extremes. Longer quiet spells that tempt complacency, then noisy runs that stack storms. Cycle shape still rides the 11-year chorus, but mid-frequency accents ride on top. Planning by rolling means misses the day that matters. Planning by cadence gives you a shot. One careful phrase started circulating in rooms that don't love sharp words. Mesoscale fusion granularity. Not cells you could draw with a pen. Volumes where transport and local composition microgradients tip conditions so energy leakage couples to magnetic scaffolding more efficiently. You don't need the core to flicker. You need preferred lanes that move energy upward faster along certain routes. Preferential leakage looks like clumps when you stand in the corona. The burn remains smooth on average. The delivery is patchy. Micro story. A postdoc ran an autocorrelation on switchback waiting times and found a shallow peak near a few minutes, variable by region. He wrote heartbeat in the margin, then replaced it with mesoscale cadence. He sent the plot to a Helioseismology friend. She overlaid a shallow P-mode envelope that drifted with latitude. The curves didn't match, they rhymed. She wrote back, enough to schedule a joint run. They did. Meanwhile, dust served as an accidental control. Near a dust-poor cavity, pickup ion signatures faded and the cadence remained. In grit-rich lanes, tiny charge exchange blooms thickened diagnostics, but the packet rhythm still cut through. Dust can tilt a spectrum and add a trickle of heat. It doesn't write a schedule. The drummer keeps time either way. Where does the beat begin? One plausible chain starts with Magneto-Gravity waves in the radiative interior, low-degree modes that beat against rotation, modulating stratification by tenths of a percent. That's small, but in a system where fusion rates and buoyancy are sensitive, small is enough to focus shear in the Tachocline along shifting bands. Concentrated shear forges stronger toroidal fields intermittently. Those bundles rise along preferred channels through the convection zone, emerge in neighborhoods, braid the corona, and set the switchback trains. The cadence isn't a metronome. It drifts, syncopates, and sometimes stacks with the solar cycle baseline. Stakes again, nailed to decisions. A launch window into a lull is a cruise. The same window during a packet-rich week is a dose. A grid operator with cadence on the dashboard can pre-stage cruise for a cluster stretch, move maintenance off the wrong Friday, and save a transformer. A satellite operator can raise altitude before a 2-day drag swell instead of after. Timing turns into mitigation. Language, as usual, tried to soften the edges. Drafts that wrote packetized transport implies non-uniform input became transport nonlinearity. Fractured core died in committee. Heterogeneous pathways survived. The science didn't change. The verbs did. Microstory pressure addition. A junior pi pitched a triptych, Parker cadence, footpoint mapping, and a rotation harmonic neutrino search. The science score came back high. The management note read, cross-division risk, advise focusing scope. She cut the neutrino aim, reframed cadence as method validation, and passed. The test that would have tied rooms together waited for another call. Here's the hinge you can actually pull without waiting for permission. Build cadence products into public feeds. Switchback waiting time ribs, packet, temperature coupling, openness maps for coronal hole boundaries. Schedule helioseismic asymmetry runs during Parker's strongest beats. Pre-register neutrino rotation harmonic searches for those same windows and post nulls fast. If the patchwork stops at delivery, neutrinos stay flat. If it reaches deeper, a whisper might ride the bar line below 1%. Either answer moves the model from slogan to score. Because the sun we're living under isn't a smooth pour. It's a city grid at rush hour, surges, brownouts, neighborhoods drawing unevenly, traffic waves that travel without a single car knowing why. We don't need to pave new laws of physics to survive it. We need to admit the lanes exist, learn the rhythm, and plan like the drummer matters. Language games and quiet redactions. Push the patchwork one layer down and the tone in the room shifts, not first in the numbers, in the nouns. You watch it happen line by line. A preprint goes up with teeth. Packetized heating implies non-uniform energy input originating below the convection zone. 2 months later, the journal version keeps the figure and files the teeth. Impulsive events refine models of energy transport. Same plot. Softer verbs. You can almost hear the grant reviewers unclench. Stakes first. Language is how risk moves through committees. Challenges spooks program officers who need to defend line items on Capitol Hill. Extends slides through. Careers are made of acceptable doubts, not sharp declarations. Real people learn to swap evidence for with consistent with, because one gets you a telescope slot and the other earns you a meeting. Action looks like a choreography you only notice once you've seen it twice. A PI emails a press office. We found a cadence that ties to root motions. The draft release quotes them. Our results suggest the standard model is incomplete in important ways. The reply comes back with track changes. Extend replaces incomplete, feature replaces anomaly, tension becomes under active investigation. It isn't lying, it's temperature control. Grow story. A postdoc titles her manuscript Non-Uniform Engine Fractured Transport. Her mentor books a quiet room. He doesn't doubt her plot, he doubts the word engine. Call them pathways. She changes the title to Heterogeneous Pathways in Solar Energy Transport. Reviewer 2 still bristles at heterogeneous. The editor suggests spatial variability. The figures pass. She gets the talk. She keeps a private copy with the old title in a folder named What I Meant. Meanwhile, conference talks learn to live twice. Version A for the room, where people will ask hard questions and nobody clips you for a headline. Version B for the live stream, where a program officer might drop a timecode into an email thread. The cadence heat map shrinks in version B. The quip about the quantized quiet sun becomes intermittent behavior. The joke dies so the grant lives. FOIA won't deliver villains, it delivers timing. Let's coordinate messaging with partner agencies. Consider posting after the budget review. Advise authors to avoid language implying model failure. That last one hits like a tuning fork. Nobody hides data, they hide direction. You feel it most when the sentence that would force a test gets cut for sounding premature. Micro Story Hallway Edition. A student shows a slide linking Parker's switchback ribs to a shallow P-mode envelope. The room leans in. Senior scientist says, half kidding, "Don't put that on YouTube." The student laughs, then changes the order of slides for the afternoon's public session. The link moves to backup. Afterward, a stranger stops them in the corridor and says, "That was the plot. Show it next time." The system has habits. Calls for proposals praise high heritage, low risk, and mature models. If your science case includes clumpy energy input from below, you're told to focus scope, which is committee speak for don't make me defend new words. Mission traceability matrices bend instruments toward yesterday's questions. If cadence is the hinge, cadence is what the matrix forgets. Impact is subtle and huge. If the strongest words disappear, urgency drains from the room. Review panels never see the edge you sanded off. They score a safer paper and a narrower mission. The next call cites incremental advances, while the physics lives outside the increment. The public hears refinement and plans for rain when a train of storms is forming. Micro-story panel call. A reviewer writes, the authors overstate implications of intermittent heating for the solar interior. Another adds in the margin, replace implications with connections. The authors comply. In the summary to headquarters, the manager notes, Pi responds well to feedback, scope appropriately focused. The project gets a smaller award. The measurement that would have forced an answer waits another cycle. Meanwhile, the neutrino paragraph keeps finding the appendix. A first author drafts, we pre-register a rotation harmonic search during Parker's cadence windows. Senior co-author says, we'll spend 3 pages defending a null. They relocate the section to supplementary. The analysis never gets scheduled. Later, at a coffee pot, someone says, we should just look. Everyone nods. Nobody has time coded for maybe. Press officers aren't the enemy. Their job is to prevent calls at midnight. They prefer extends, informs, opens a window. They kill appends, breaks, forces revision. It keeps the inbox calm. It also keeps the public thinking the sun is a metronome with a quirky chorus instead of a drummer with bad manners and excellent timing. Stakes again pointed at people who keep systems alive. Grid operators don't need euphemisms. They need windows when clusters are likely. Satellite controllers don't need refinements. They need cadence indices posted in plain English. Astronauts don't need a smoothed index. They need to know when the packets stack. If the verbs stay safe, the dashboards stay blind. There's a way out that isn't a fight, it's a template. Let the figures speak publicly and fast, cadence ribs, switchback waiting time histograms, packet, temperature coupling, clearly labeled experimental. Allow multiple verbs in the same ecosystem. If one team says requires revision and another says extends, fine, so long as the numbers match. Pre-register the tests that scare you. Neutrino rotation searches during Parker windows. Tachocline asymmetry maps at weekly cadence when the drum is loud. Publish nulls like wins. Micro-story, small courage. A data analyst sneaks a cadence metric into the public feed with a note. Prototype use at your own risk. A junior pi leaves non-uniform in a caption after 3 rounds and sends a supplementary page of stats to the editor. A program manager adds 1 line to a call. Proposals addressing cadence, packet statistics, Tachocline asymmetry, or time domain neutrino searches are encouraged. Nobody loses their job. The room gets a little freer. Because secrecy isn't the problem, inertia is. The sun already told us its song. Our verbs are the filter. Stop sanding the notes and the tests write themselves. The neutrino thread reconsidered. The sun has a heartbeat. Neutrinos are the one sound that isn't muffled by the blanket. They're born in the core's fusion chains, ghost through matter like it isn't there, and reach us 8 minutes later with almost no edits. They're supposed to be steady on human timescales. Fusion doesn't lurch hour to hour. That's why, after the 196's missing neutrino problem fell to flavor oscillations, the field relaxed. Fluxes matched standard solar models within uncertainties. Crisis over. Case closed. Except Parker's cadence put a question back on the table. Is there any trace of rhythm in the one messenger we can trust? Stakes first. Neutrinos scale brutally with temperature in the core. The 8B branch, the rare high-energy tail, goes roughly like central temperature to the 25th power. 0.1% wiggle in TC would look like a few percent nudge in that flux, small at the detector, huge at the source. If a sub-percent modulation exists and lines up with Parker's strongest cadence windows, the clock reaches deeper than transport. If there's nothing, the patchwork lives above. What actually sits in the record is a solid baseline with itchy edges. SNO and Super K locked down the flavor story. Borexino delivered precision on 7B and PEP, and a hard-won detection of CNO neutrinos that finally put numbers on the metal-catalyzed branch of the fusion chain. Global fits land the total 8B flux within a few percent of standard models, 7B within similar bounds, PEP tighter still. The CNO rate favors higher metallicity at face value, but systematics leave room for both the high Z and low Z compositions still argued over in Helioseismology circles. The safe sentence survives, consistent within errors. Time series searches add the itch. Analysts have binned years of events looking for peaks near the 27-day solar rotation or its harmonics, hunting for any modulation beyond the trivial 1/R2 seasonal variation. Hints appear, then soften when you adjust background cuts, energy thresholds, or day-night splits. Nobody clears 5 sigma. The careful line persists. No statistically significant periodicity. The physical stakes don't vanish, because a 10th% drum would hide under that bar, unless you go looking with intent. Meanwhile, we've eliminated the flashy culprits. Exotic neutrino magnetic moments flipping spins in strong fields, constrained away for the strengths and scales that matter. Sterile neutrinos. Interesting for other puzzles, not demanded here. You don't need new particles to get a whisper. You need structured, tiny perturbations in stratification or composition that slightly tilt reaction rates in a way the photon luminosity won't show for 100,000 years. Neutrinos don't wait for photons. Microstory. A young analyst at a neutrino lab ran an unofficial cross-correlation. Parker's switchback cadence index versus her detector's daily 8B event rate, pre-whitened and scrubbed for the obvious season and detector drift. She found nothing she could publish, just a shallow bump that slid if she changed energy windows. She printed the plot anyway, taped it inside her notebook, and wrote "need statistics, not wishes." Then she sent an email to a Parker collaborator. "Tell me your loudest weeks. I'll pre-register the test." Impact lands in how we plan the next round. Juno's massive statistics after reactor quiet periods, Hyper-K's volume, SNO plus with cleaner backgrounds. These are the machines that can hear a 0.5% hum if it's there, but only if they listen on purpose. That means pre-registering rotation harmonic searches tied to Parker's strongest cadence windows, not fishing ex post. It means publishing nulls fast, with systematics pinned where anyone can check, so we stop confusing discipline with silence. There's also a composition hinge that matters more than it sounds. Borexino's CNO measurement, modest as it is, leans toward higher core metallicity, the high Z side, which helps heliosismic fits in some layers and complicates others. If the core is richer in metals, opacities rise, central temperature edges up, and the 8B tail follows. That pushes fluxes in the same direction that a tiny rhythmic modulation would nudge them. Untangling the steady from the scheduled is the job, which argues for joint campaigns. Heliosismic asymmetry maps, Parker cadence, and neutrino time series on the same calendar. Language, as usual, plays goalie. Papers write consistent with standard solar models and bury the time domain appendix. Press releases celebrate first direct CNO neutrinos and omit that the result brushes against the metallicity debate that keeps Helioseismologists up late. Reviewers ask whether rotational searches are premature given current systematics. The clock doesn't care. If there's a whisper, it's already playing. Here's the hinge we can pull without melodrama. Pick windows when Parker's cadence index spikes. Register the neutrino analysis recipe ahead of time. Energy bins, background model, harmonics to test, calendar alignment. Run it. If the line comes back flat, we've learned the beat lives in delivery. If a sub% wiggle survives discipline and rhymes with the switchback drum, the patchwork reaches farther down than we thought. Either way, the model moves from metaphor to measurement. Because neutrinos are the one part of this story that doesn't have to ask permission. They pass through everything we don't understand and tell us whether the heart changed tempo or the hands simply changed technique. If the hands alone wrote the rhythm, Parker has already shown us where to watch. If the heart ever twitches on the bar line, we'll hear it there first. Dust fields and a hidden dynamo. Then the plasma started crunching on grit. Near Parker's closest dives, instruments picked up tiny impacts, millisecond swells in electric fields, pick-up ions appearing out of nowhere, brief sprays of electrons. Not empty space, but a haze of nanodust and neutral atoms skimming the inner system, charged and light enough to dance on magnetic field lines. Each hypervelocity hit vaporized into a microplasma cloud. Fields could hear them as spikes. SWAP saw the newborn ions fold into the wind. Stakes first. If dust tweaks the soup, then every clean measure of heat, flow, or turbulence inherits bias. You can mistake dust-borne pickup ions for extra heating, or miss how much energy the field alone is delivering. For people who plan satellites, that means drag estimates go soft. For crews headed beyond Earth's shield, dose models drift. For the grid, it's whether a forecast calls a 3-day cluster or a 1-day blip. What actually happened looked like fingerprints on glass. As Parker skimmed perihelion, pickup ions surged in step with dust density models, and electrostatic signatures bloomed around impacts. At the same time, magnetic switchbacks strolled by like a parade, and temperature anisotropy rose in the same windows. Dust didn't write the melody, it thickened the harmony. Then the control case arrived, a dust-poor cavity near the sun. Crossing its edge, dust signals dropped. The cadence stayed. Subtract grit, the drum still plays. Meanwhile, the switchbacks themselves lined up like tracks across a map, not random kinks but footprints along invisible roads. Those roads point down to the Dynamo, a machine we sell in classrooms as a steady converter of rotation and convection into global magnetism. Parker's cadence hints at a dynamo that breathes, a system that exhales in pulses. Not a single metronome, sections trading the beat. Action inside the data tightened that idea. In alignment windows with solar orbiter, the sharpest folds near the sun mellowed into microstreams downstream, the same cadence stretched over distance. Backmapping those patches to the photosphere put a lot of roots along coronal hole boundaries and the flickering edges of ephemeral regions. Interchange reconnection loves those doors, closed loops snapping onto open field, injecting stress and jets. The timing, near regular spacing in some runs, asked for a deeper clock than granulation. Here's one route that fits the footprints. Deep inside, Magneto-Gravity waves beat against rotation, slightly modulating stratification. That focusing nudges shear into bands in the Tachocline, the forge. Concentrated shear builds toroidal fields intermittently. Buoyant bundles rise along preferred channels through the convection zone, break the surface in neighborhoods and braid the corona. Where braids load, switchbacks follow. Where switchbacks relax, the wind accelerates and heats in packets. A breathing dynamo ties the chain. The dust only colors the edges. Microstory. A grad student overlaid 3 Parker perihelia, time-of-flight corrected switchback patches, and fit a toy shear model pulsed by a low-frequency interior wave. The match wasn't perfect, it didn't need to be. A senior in the back said, "That's a drummer, not a bell." The student labeled the plot toy, sent it to a Neutrino colleague, and asked a simple question. "If this pulse mattered at 0.3%, could you hear it?" The reply was one line: "With time and discipline." Impact lands hard on forecasting. A breathing dynamo reshapes open field topology, which is the highway CME's use. Change the highway and you change whether an eruption threads Earth's magnetosphere or glances off. Stack that with Parker's evidence for extended corotation, fields dragging farther and faster than old models allowed, and you've got trajectories bending more than we budgeted. That's how a quiet forecast turns into 5 loud days. It's also how a Mars mission's safe month becomes a gamble. Meanwhile, Parker's dust records turned into a tool, not a nuisance. The team used impacts as tracers of local field geometry, plasma clouds ringing like handbells when they hit sharp gradients. In some runs, the impact rate dipped as switchback cadence rose, and vice versa, an anti-correlation that helped isolate magnetic heating from chemistry. In others, dust boosted background charge just enough to change wave damping. Either way, the cadence remained the signal, dust the knob. Language tried to keep the pulse indoors. Papers wrote intermittent dynamo output and pulsed magnetic energy release. Press pages softened to a new window on the sun's magnetic heart. The unsaid part is simple. Rhythms imply clocks, and clocks imply planning. A cluster week isn't a surprise, it's a bar in the score. Microstory Operations Addition. A space weather desk added 1 new row to the dashboard. A cadence index computed from switchback waiting time ribs posted as experimental. The first time it spiked, they issued a quiet cluster risk note. 2 days later, back-to-back CMEs merged and wrote a high-speed stream. The storm didn't end on schedule. Afterward, a utility wrote, "We moved maintenance. You saved us a transformer." Here's the hinge sentence the data already earned. Dust can tilt a spectrum, but it can't fake a drum. The drum beats where the dynamo breathes. And if the engine has a pulse, timing stops being trivia. It becomes the difference between a long weekend and a long repair. Timing the sun, cycles that don't behave. Here's where the calendar starts lying to us. We teach the 11-year cycle like a school year. Sunspots rise, peak, fall, reset. Then cycle 25 showed up early and lopsided. High-latitude spots bloomed ahead of schedule, flux patterns skewed north versus south, and the butterfly diagram, those graceful wings of migrating activity, picked up ragged edges. Forecast panels hedged. The sun didn't. Stakes first. Cycles aren't trivia, they're logistics. Airlines route polar flights differently in hot months. Satellite drag budgets depend on thermospheric swelling. Launch windows for deep space missions hinge on radiation tides. Grid operators plan maintenance around quiet weeks. When the beat drifts, plans turn into wagers. What actually happened was a series of small misfires that added up. Polar fields, the seeds of the next cycle, grew unevenly, stronger in one hemisphere, slower in the other. Meridional flows, the conveyor that hauls magnetic flux poleward, wobbled, speeding some months, stalling others. New bipoles popped with tilt angles that pulled harder on the dynamo feedback than models expected. And in magnetograms, you could watch flux ropes rise where the butterfly map still showed empty lanes. The driver wasn't off, it was slipping gears. Meanwhile, Parker started handing us a way to hear the slip as it happened. During months when high-latitude emergence ran hot, switchback patches thickened near the sun, their waiting times clustering tighter. Farther out, solar orbiters saw microstreams fatten in step. The cadence didn't mirror the sunspot count 141, but the family resemblance was loud, a drummer changing subdivisions while the chorus kept time. Weeks later, the thermosphere puffed and small sets sank faster. Operators who planned for a single swell got a stair-step instead. Impact landed on every playbook we thought we could trust. Flux transport dynamo models, the backbone of cycle prediction, can reproduce the butterfly if you pick meridional flow profiles just so. But those flows aren't just so, they wobble. Add in latitudinally textured Tachocline shear, the banded forge Parker and Helioseismology keep hinting at, and you end up with hemispheric asymmetries that persist through a cycle. North peaks, south lags. CMEs born under a lopsided corona thread different magnetic highways, so their trajectories bend differently. That's how a moderate week on the index becomes 5 stubborn days on the ground. Stakes again, this time with dates and dollars. In May 2024, storms arrived in a train CME, then another, then a high-speed stream coupling into the same field geometry. Auroras hit latitudes that don't budget for them. Precision agriculture lost GPS reliability at the wrong hours, planting depth wandered, losses stacked into the hundreds of millions. None of that looked exotic from afar. It looked like just another week, until the cadence turned it into a season. Action inside forecast rooms started to shift. A forecaster pinned a note: treat the sun like weather, not a calendar. They added a cluster risk advisory based on 3 dials, Parker's switchback rib index, an openness gauge for coronal hole boundaries, and a short-range metric for hemispheric asymmetry. The first time the index spiked, they issued the note quietly. 2 days later, back-to-back CMEs merged en route and rode a high-speed stream. The storm didn't end on schedule. Afterward, a utility wrote, "We moved crews, you saved a transformer." Meanwhile, the long archive reminded us this isn't new, it's normal we forgot. Tree rings and ice cores, radiocarbon and beryllium, record centuries of grand minima and maxima, beats riding on top of the 11-year chorus. Maunder, Dalton, Glesberg-like modulations. The sun stacks rhythms. We smoothed them out to teach, then built models that loved the smoothing. Microstory. A mission planner working a Mars window kept 2 spreadsheets, one with the classic solar minimum heuristic, one keyed to cadence. The classic sheet said green. The cadence sheet ticked amber on the exact week their trajectory wanted. She took heat for moving the launch by 9 days. The week they skipped turned into a pulsed particle shower. She didn't say, "I told you so." She printed the plots and taped them to the wall. Here's the hinge sentence that changes how we plan. The 11-year cycle is the chorus, not the whole song. On top of it ride mid-frequency accents, weeks to months beats seeded by shifting shear bands and gated delivery. Exactly the scales Parker's cadence hears. That's why flare productivity spikes can show up between expected peaks, why drag can stay high for days after an index drops, why a quiet forecast becomes an expensive Tuesday. Forecasting the next decade still needs the chorus. Keeping hardware alive needs the accents. So we start scheduling around rhythm. We align helioseismic campaigns with Parker's loud weeks to watch shear bands breathe in real time. We add cadence to public dashboards, switchback ribs, packet temperature coupling, openness geometry in plain language. We write advisories like weather with windows and odds, not just single number indices. And we train ourselves to hear the drummer, because the sun isn't late or early. It's playing a part we finally have ears for. The institutional backstop. While the sun was busy playing rhythms, something quieter shaped how those rhythms reached anyone outside a lab. It didn't start with data. It started with budgets, briefings, and a survival instinct baked into institutions that have to promise certainty to keep their lights on. Inside a program office, risk has a vocabulary. Refinement is safe. Revision is not. Extends is welcome. Appends triggers a memo. If your proposal says non-uniform engine, someone will underline it and write scope, because scope is the lever managers pull when they can't pull physics. Missions live or die on traceability matrices that tie each instrument to mature theory. If Cadence is the hinge and Cadence wasn't in last decade's matrix, you're told to focus on achievable sub-aims. This isn't a conspiracy, it's inertia with deadlines. But inertia trims edges. A small cut here, remove requires and use informs, and a bigger cut there, move the neutrino timing search to supplementary. And suddenly the one test that would settle whether the beat reaches below the Tachocline doesn't get funded this cycle. Another mission inherits yesterday's questions by design. Microstory. A Pi pitches a coordinated campaign, Parker Cadence windows, solar orbiter footprint mapping, weekly helioseismic asymmetry maps, and a pre-registered neutrino rotation harmonic search. Science score, excellent. Management, cross-division coordination risk, recommend narrowing. She trims the neutrino aim, reframes Cadence as method validation, and passes. The bright line test waits another year. Peer review becomes the culture's thermostat. Referees don't say, "Don't rock the boat." They say, "Overstates implications." The fix reads like a lesson. Replace implications with connections. Evidence for with consistent with. A grad student learns to preempt that note before it arrives. 10 such edits later, a field sounds reasonable and feels less urgent. Press offices run the same play for different reasons. Their job is to prevent midnight calls from people whose jobs depend on predictable benefits for society. So the draft that says packetized heating implies gating below the convection zone leaves the building as impulsive events refine models of transport. The figure is the same. The verbs are. The public hears a tidy story. The operators who need cadence see none. FOIA won't hand you a villain. It hands you timing. Coordinate messaging across agencies. Consider posting after the budget review. Avoid language implying model failure. No numbers are buried, direction is. The test that would force a new instrument becomes future work, and future repeatedly means not in this call. Microstory. A conference talk shows a cadence, temperature coupling plot that makes a room lean forward, then vanishes from the archived recording, replaced by an updated deck where the heat map is smaller and the word quantized becomes intermittent. The scientists didn't lie. They survived. Afterward in the hallway, a grad student whispers, "That was the slide." The speaker nods like they already knew. Meanwhile, mission traceability matrices harden. They reward high heritage, low risk, clear path to impact. That's how you keep a flagship alive across administrations. It's also how you build instruments that take better pictures of the same question instead of turning to face the new one. If cadence belongs on the dashboard, cadence needs a row in the matrix. Without it, the best you get are side-channel products built by engineers on their own time. The cost lands where most people will feel it. A forecast that misses clusters turns a 2-day event into 5. A launch that trusts a smoothed index flies into a pulsed shower. A grid that sizes spares for single hits meets a week of hot copper. None of those failures will ever read verbs were too soft. They'll read unforeseen conditions. The conditions weren't unforeseen. They were unspoken. There's a way to bend the machine without breaking it. Start with 3 sentences in a call. Proposals addressing cadence, packet statistics, Tachocline asymmetry, coronal openness, or rotation harmonic neutrino searches are encouraged. Pre-registered analysis plans will be prioritized. Experimental public data products are permitted. That costs nothing. It buys honesty. Microstory. A program manager slipped one such line into a mid-cycle amendment. A small team applied with a cadence index, a weekly shear map, and a neutrino timing stub. They got a modest award labeled Pathfinder. 6 months later, the cadence plot showed ribs before a cluster week. A utility moved maintenance. Nobody issued a press release. The transformer lived. Press officers can help, not hinder, if the goal shifts from no alarms to clear odds. Let releases say, figures show packet timing that increases cluster risk. Let ops dashboards post experimental cadence ribs, packet temperature coupling, and openness geometry with caveats in plain language. Give the public a rhythm bar next to KP. Don't promise storms, promise windows. Peer review can reward tests instead of outcomes. A paper that says we pre-registered a null should be a citation, not a shrug. Editors can keep the neutrino paragraph in the main text when the calendar aligns with Parker, even if the answer is not yet. Panels can read non-uniform as a target, not a threat. And inside labs, run 2 cultures openly. The morning group meeting where people say the sentence that matters, and the afternoon media prep where verbs land softer. Then give the morning sentence a public home, a figure repository that posts the ribs and the coupling with a banner that says provisional. If you need a template, steal one from Weather. Because what's at stake isn't pride, it's planning. The sun won't simplify for our budgets. Institutions can still move fast enough to publish cadence, schedule joint runs, and test the one quiet hinge neutrinos offer. We don't need a scandal to change verbs. We need permission. And the sun already gave it to us by playing the beat where everyone can hear, if we stop turning the volume down. The composite picture, a non-uniform engine. Put the pieces on one table and the outline sharpens. Switchbacks arrive in trains. Bursty heating tracks those trains. Microstreams downstream carry the same spacing after time of flight. Helioseismic maps show shear bands with texture that shift across weeks to months. Neutrino fluxes sit within error bars, but just close enough that a disciplined sub% search tied to Parker's loud weeks would matter. Thus thickens the soup without writing the song. That doesn't spell collapse. It spells a star that delivers power through lanes, not a single pipe. Stakes first because this isn't academic. A non-uniform engine fattens the tails that hurt us. Clusters of CMEs coupled to a packet-rich wind stretch a one-day storm into 5. Thermospheric density stairsteps. Small sets sink faster. GNSS errors spike at the wrong hour and farm equipment plants shallow. A crew headed for Mars threads a quiet window or flies through a pulsed shower they could have dodged if cadence were on the dashboard. Hazard lives in timing. What actually fits is a family of models with one shared move: gating. Deep Magneto-Gravity waves nudge stratification by 0.1% and beat against rotation, focusing shear into bands in the Tachocline. Concentrated shear forges toroidal fields intermittently, bundles, not blankets. Those bundles rise along preferred channels through the convection zone, emerge in neighborhoods, and braid the corona. Above, 2 tools do the unloading. Interchange reconnection opens closed loops onto open field, leaving S-shaped folds and jets. Nonlinear Openness waves steepen and carve switchbacks out of those folds. Near the sun, magnetic stress relaxes into kinetic energy. The wind accelerates in pulses. Heat arrives in packets filtered by a Helicity barrier that cooks ions more than electrons where magnetic pressure dominates. Downstream, microstreams mellow but keep the beat. Impact is immediate. Forecasting moves from climate to weather. We keep the 11-year chorus for decade plans. We add mid-frequency accents for operations. Weeks to months beats seeded by shifting shear and gated delivery. The practical dials are clear. Post a cadence index built from switchback waiting time ribs over the last 48 hours. Track packet, temperature coupling, how proton anisotropy swells inside flip clusters. Map openness at coronal hole boundaries from magnetograms, updated daily. Those 3 together flag cluster risk before a train forms. Meanwhile, the neutrino hinge stays honest. We don't need the core to flicker. We need the delivery system to imprint a bar line. But if the deep beat ever leaks into the core's temperature by 0.1%, the 8B tail nudges a few %, detectable with enough care. So we pre-register rotation harmonic searches in Juno or Hyper-K during Parker's loudest weeks. Publish nulls fast. If it's flat, the patchwork stops above. If a whisper survives discipline and rhymes with cadence, the network reaches deeper than we thought. Micro story. A forecaster taped 3 plots above their desk, ribs up, coupling up, openness changing fast in the same hemisphere. They issued a quiet cluster risk advisory, odds not hype. 2 days later, CME interaction lit up WISPR. The storm rode a high-speed stream and lingered. Afterward, a utility sent one line. We kept crews on, transformer fine. The plots stayed taped up. Language doesn't need to carry this by itself. Figures can. Parker's cadence and coupling go on a public page labeled experimental. Helioseismic shear maps post weekly, uncertainty bars included. Solar orbiters footprint movies sit beside them. One neutrino lab adds a listening now banner during Parker's loud windows, with a promise to post results, flat or not, on a fixed date. Coordination turns into culture when the calendar, not the press release, sets the tempo. The model even explains the old misses. Extended co-rotation keeps the field's hand on the wind longer, bending CME paths more than standard models assumed. Hemispheric shear asymmetry seeds lopsided cycles, eruptions born under different topologies coupled differently to Earth. That's why a middling index becomes a hard week on the ground, why drag can stay high after the knob turns down, why a quiet month ends with a drum roll. We don't need to sell a scandal, we need to fund tests. Give modelers a target, forward predict cadence drift with latitude for the next Parker pass, and publish the calendar before the dive. Give instrument teams a mandate, near real-time ribs, coupling, and openness gauges within hours. Give neutrino groups runway to listen on schedule. Give Helioseismology time blocks tied to cadence, not conference dates. Because the composite picture isn't a slogan, it's a workflow. A sun that gates delivery through lanes will keep sending packets whether or not we admit it. The only choice left is whether we plan like the drummer matters, or act surprised every time the beat lands on a Tuesday. Human cost and career gravity. The rhythm is physics, the pressure is human. You feel it first in small edits, then in careers that bend. A young scientist sits with a draft that says what the plots say. Ribs in the cadence, heat pulsing in lockstep, roots that line up on certain weeks. She knows the verbs are sharp. She also knows the grant deadline is Friday and her committee reads between the lines. Her mentor circles non-uniform engine and writes pathways. She changes it. The figures stay. The spine loosens. She gets the interview. She doesn't sleep well for 3 nights. Stakes land in paychecks before they land in journals. If your phrases sound like revision, reviewers hear risk. If your talk title hints at a drum in the Dynamo, someone will ask if you've overreached. 1 word becomes a month becomes a cycle. Multiply by a cohort and the field slows without anyone ever voting to slow it. Action inside labs looks like 2 scripts for the same truth. Morning group meeting, people say the sentence that matters. The switchback ribs and temperature anisotropy rise together so timing isn't noise. Afternoon media prep. Soften the nouns, add consistent with, cut the neutrino paragraph to supplemental. It isn't dishonesty, it's a survival skill. But every time you move a hinge to the appendix, you move the test to next year. Micro story. A postdoc builds an autocorrelation of Parker's flips and finds a shallow rib near a few minutes, drifting with latitude. He labels it cadence metric, not heartbeat, because he wants the job. At the poster, an older scientist taps the axis and says, "It's okay to call a drum a drum." The postdoc smiles, then adds 3 references to turbulence literature so no one thinks he's waving a flag. He gets the fellowship. The slide that said drum never makes the archive. Meanwhile, conference culture trains reflexes. 10 minutes on stage is nothing. You can show the plot that makes people lean forward, or you can explain why it matters. You can't do both. So you show the plot, say intermittent, and hope for the right question. If the chair says, "One last quick one," it's about color scales. On the way out, 2 grad students stop you and whisper, "We saw it." You nod. They'll either keep the word, non-uniform in their captions, or learn to hide it like everyone else. The cost spills into operations. An analyst on a space weather desk tests a cadence index on their own time. No funding line, no mandate, just curiosity and a hunch that clusters matter. The first week the index spikes, they send a quiet cluster risk note to a utility contact who once asked for anything better than a smooth KP. After the storm lingers, the contact writes back, "We moved crews. You bought us a transformer." The analyst prints the email and tacks it up behind their monitor. Their manager says, "Nice, keep it low-key." The index remains experimental for another quarter. Microstory. A Neutrino grad schedules an unofficial rotation harmonic search during a Parker Loud week. She pre-registers her cuts in a shared lab doc and tells 2 people. The result is flat within her errors. She posts the null to the internal channel anyway. A senior replies, "Thanks for looking." No paper, no fanfare, but the habit catches. The next window gets a real slot on the calendar. Careers bend around who protects whom. A senior PI shields a junior author who keeps non-uniform, in a caption by offering to take the reviewer fight. A program manager slips one line into a call, time domain analyses encouraged, and 3 small teams apply with Cadence products that never would have cleared last year. A press officer agrees to put the Cadence heat map on the public page with a big red experimental banner and a paragraph of caveats. Nobody gets fired. The inbox doesn't melt. The figure gets bookmarked by an ops center you'll never tour. There's also the opposite story. A team with an elegant, careful simulation that keeps everything smooth gets the keynote slot. Their plots are gorgeous, gradients, averages, confidence bands. During Q&A, someone asks about packets and ribs. The speaker says, "That's a refinement we'll capture with more resolution." The room nods because the room wants a world without schedules. Out in the hallway, a satellite engineer looks at their phone, checks the cadence index and texts a colleague. "Hold the maneuver 2 days." The gravity of careers pulls language toward safety. That's why you need structures that reward the risk of saying the sentence out loud. Calls that prioritize cadence, packet statistics, shear asymmetry, and rotation-tuned neutrino searches. Editors who keep time domain paragraphs in the main text when the calendar lines up with Parker. Dashboards that post ribs and coupling with disclaimers, not delays. Panels that score pre-registered nulls like wins because they are. Microstory, last one. A graduate student after a talk admits she cut the slide that tied switchback ribs to a shallow P-mode envelope. It made the talk too busy. A stranger says, "That was the slide." She puts it back next time. The question she feared doesn't come. 2 emails do, one from a panelist asking for clarification on scope, and one from a utility operator who writes, "If you ever post that rib index daily, send me the link." She pins the second email to her wall. The first goes in a folder called Cost. The coming passes and what to watch. The next Parker divies aren't just closer, they're timed against a noisy star mid-performance. This is pattern discrimination now. What a patchwork engine predicts versus what a smoothed model would show. If the drummer's real, the data should leave ribs you can't sand away. Start with field geometry. Near perihelion, expect switchbacks to arrive in patches, not random flips, but clusters with preferred separations that repeat within a pass and reappear after time of flight and orbital phasing corrections. Compute waiting time histograms on board or near real time on the ground. In a smooth outflow picture, the autocorrelation should flatten quickly. In a packet model, it leaves ribs, secondary peaks at a few minutes, drifting with latitude and evolving over days. Tie those ribs to heat. SWEAP and FIELDS should see proton temperature anisotropy swelling inside switchback clusters and relaxing between them, not as gentle waves but in step-ups and plateaus. Electrons should sprout wings, non-Maxwellian tails on the same beats. If turbulence alone is setting the table, phases should smear. If gating drives delivery, heat traces cadence. Look for downstream echoes. Alignment windows with solar orbiter are gold. Microstreams farther out should inherit the near-sun spacing. mellowed but measurable after time of flight. Cross-correlate Parker's rib index with orbiter's microstream intensity over days. A surviving peak is an echo. No peak says the cadence died early. Backmap the routes. Use ballistic or more advanced connectivity from Parker's track to the photosphere, then overlay high-cadence magnetograms. Packet sources should pile up along coronal hole boundaries and ephemeral region fringes. The tell isn't location alone, it's timing. Footpoint burstlets, quasi-periodic motions, then packets overhead. If the route writhes without rhythm while the corona pulses on time, the clock lives deeper. Dust is the control knob. As Parker skims the edge of the dust pore cavity, pickup ion signatures should drop. If the cadence is magnetic at heart, the ribs and packet, temperature coupling persist or sharpen with cleaner plasma. If chemistry is faking part of the pattern, ribs soften when the grains go quiet. Use the contrast to isolate magnetic heating from sawdust. Watch the rotation handoff. Extended co-rotation surprised everyone. It shouldn't surprise us again. Measure azimuthal flow and field alignment as Parker moves through the Openness transition. If co-rotation persists stronger or farther than old models, CME path forecasts need that bend. Pair that with cadence and you can flag weeks when stacked ejecta are more likely to merge and linger. Now bring neutrinos to the calendar. Quietly, deliberately. Pre-register rotation harmonic searches in windows when Parker's cadence index spikes. Post the recipe ahead of time. Energy bins, background models, harmonics to test, and fix stop dates for public posting. A flat line says the beat lives above. A sub% nudge that tracks the same bars hardens the patchwork's reach. Nulls are answers. Post them fast. Helioseismology gets an appointment too. During Parker's loud weeks, run targeted inversions for Tachocline asymmetry at weekly cadence. Let latitude and time breathe. Don't smooth the band into a single thickness for a pretty figure. If shear ridges sharpen on the same week's cadence rises, the Dynamo's pulse steps into view. If not, you've narrowed the clock's home. Build 3 dials for public dashboards. First, a cadence index. A simple rolling autocorrelation rib score of switchback waiting times over the last 48 hours. Second, a packet temperature coupling metric, how tightly proton anisotropy tracks flip clusters. Third, an openness gauge, daily maps of coronal hole boundary geometry in the hemisphere Parker samples. Together, they flag cluster risk before indices move. Label them experimental. Operators don't need perfect, they need early. For operations, set habits. Satellite teams tie drag planning to cadence spikes, not just solar flux. Reboost before a stairstep, not after. Grid operators shift maintenance off windows when cadence and openness shift together. Crewed mission planners slide launch a few days to avoid pulsed particle showers you can see coming. Odds, not promises. Modelers go first. Publish calendars, not just curves. If your intermittent shear model predicts a latitude-dependent cadence drift, write dates before the pass. If your wave-steepening code says ribs should tighten near certain longitudes, pin them to a week. We don't need consensus, we need falsifiable bars. And expect the sun to ignore our plans. Log the misses. On quiet trip days, note what else changes. Charged states, electron straws, superthermal tails. On loud rib days, track how quickly downstream microstreams fatten and whether geomagnetic indices lag by the same hours twice. Build a ledger of lags and echoes that turns anecdotes into timing. One more watch, language. If a paper lands with figures that show ribs and coupling but verbs that say refines, cite the plots and say the sentence out loud calmly. The star isn't a metronome. Treat rhythm as a parameter, not an anecdote. The coming passes can prove it if we listen in time. Consequences if the core isn't smooth. If the engine breathes, risk clusters. CMEs don't just pop, they cue. A single ejecta is a bad day. 3 in phase with a high speed stream is a 5-day grind. Transformers run hot, protective relays chatter, and a maintenance window turns into a scramble. Thermospheric density stair steps. Small sets sink early. Collision screens light up while operators burn fuel on the wrong morning. Astronaut dose isn't a yearly average. It's the hour the drummer speeds up. A Mars crew that threads a quiet bar cruises. Miss by 2 days and a pulsed shower doubles exposure before anyone can pivot. GNSS errors spike at planting time. Depth and spacing wander. A few mistimed hours grow into millions in lost yield. High-frequency traders see nanoseconds drift. Airlines reroute polar flights late and eat the cost. Models built on smoothness mise-aim shields and budgets. You size for a hit, not a sequence. You forecast storm arrival, not the linger. The fix is rhythm-aware planning, cadence on the dashboard, cluster risk in advisories, reboosts before stair steps, crew EVAs inside quiet bars, grants that fund tests tying Parker's ribs to helioseismic breathing and neutrino windows. Not hype, habit. The star won't simplify. We can plan like timing matters. What should be said out loud? We need to change how we talk, inside labs, inside agencies, and out where the people who rely on this star make decisions. Start with the vow we keep in private and dodge in public. Say the uncertainty without spin, and say the stakes without theater. If a plot shows packets marching in time and our models can't explain the cadence, don't bury it under refinement. Write what we actually say to each other after the meeting. We don't know yet, and knowing would change plans on Earth. That means retiring euphemisms that turn questions into wallpaper. Feature is not tension. Informs is not requires. Keep the plots honest in the abstract, not just the appendix. If Tachocline inversions won't smooth without hand-tuned opacities, call it a tension and explain why that matters for how field bundles rise. If Parker's cadence index and proton anisotropy climb together for days, say that heat is riding timing, not just turbulence. If neutrinos are flat within errors but a sub% wiggle would matter physically, say that aloud. People who keep lights on can handle uncertainty. They can't handle silence. Next, change the default from consensus first to test first. Fund parallel models on purpose. Give one team a budget to build the smoothest possible sun with every transport trick you can muster. Give another the runway to couple Magneto-Gravity waves to Tachocline shear to flux emergence to coronal packets. Make both publish forward predictions as dates, not just fits as curves. Write calendars. Between these weeks, given current shear asymmetry, expect tighter ribs at these latitudes. Then hold them to those calendars. We don't need agreement to move. We need falsifiable bars we can miss. Tie instruments to the bars. Put Cadence products in the open quickly with labels that say experimental in plain English. A simple rib index from switchback waiting times, a packet, temperature coupling score, a daily openness map for coronal hole boundaries. Those 3 dials, posted within hours, give operators something to act on before the big indices move. Pair those with solar orbiters, footprint movies, and high-cadence magnetograms so the routes are visible alongside the packets. If a figure needs caveats, put the caveats one click away. Don't wait for the perfect paper. Give people the imperfect truth now. Schedule the quiet hinge neutrinos offer. Pre-register rotation harmonic searches tied to Parker's loud weeks. Post the recipe up front. Energy windows, background treatment, harmonics, stop dates. Publish nulls fast and treat them like wins because they are every disciplined nothing moves the model. If a 0.5% nudge survives discipline and matches the bar lines, the beat reaches deeper. If it doesn't, we can stop chasing ghosts and focus where the drum clearly lives. Helioseismology should stop flattening the Tachocline for the sake of pretty figures. Runtime-dependent inversions at weekly cadence when Parker's rib index rises and let latitude breathe. Publish maps with uncertainty bands that move, even if that movement makes a grant officer nervous. If shear ridges sharpen on the same weeks the packets cluster, the dynamo's pulse stops being metaphor. If they don't, we've pinned the clock higher up. Either way, we get a location, not a vibe. Then talk to the people who carry risk every day like they're in the room, because they are. Public dashboards should add one new bar, cluster risk. Not a guaranteed storm, odds that events will stack and linger. Write it in plain language, packet timing up, high-speed stream alignment likely, elevated chance of multi-day impacts. Pair it with suggested moves, shift maintenance, reboost early, avoid polar routes, schedule EVAs on the quiet side of the bar line. Treat it like weather. People understand windows and probabilities. They don't need a mystique around magnetism to move a truck. Agencies can fix inertia without betting the farm. Add 3 lines to solicitations. Proposals addressing cadence, packet statistics, Tachocline asymmetry, coronal openness, or rotation-tuned neutrino searches are encouraged. Pre-registered analysis plans will be prioritized. Experimental public data products are permitted. That phrase doesn't commit money, it commits culture. It tells early career scientists they won't be punished for writing the sentence that matters. It tells panels to score clear tests, even if the answer might be no. It tells instrument teams that posting ribs with caveats won't cost them a badge. Press offices can help by trading polish for clarity. Releases can say requires new measurements instead of opens a window. If a figure shows ribs, include it big and label it experimental, with a paragraph explaining what we don't yet know. If there's coordination across missions, sync facts, not verbs. Let one team say extends, and another say demands revision if the plots justify both reads. A monoculture of caution doesn't make the star safer. A plurality of honest sentences makes the audience smarter. Here's a small, actionable list we can start next month. Post a Parker Cadence Index and packet temperature coupling score within 12 hours of each perihelion pass, with a rolling 48-hour autocorrelation and a plain language note. Ribs strong, ribs fading. Coordinate with Solar Orbiter to pre-plan alignment windows and publish footprint maps in near real time, even if they're messy. Run weekly helioseismic inversions during Parker's loud weeks. Publish shear maps with uncertainties. No smoothing to please a caption. Pre-register neutrino rotation harmonic searches for those same weeks and post nulls on a fixed date. No waiting for perfection. Add a cluster risk bar to public space, whether dashboards and write advisories like weather, windows, odds, and suggested actions. Protect the people taking these risks. Create review lanes that reward high-impact tests with clear outcomes, yes or no, over tidy stories with no skin in the game. Fund fellowships that cross walls, interior waves on Monday, Parker packets on Thursday, because the physics doesn't respect journals. Give junior authors air cover to keep non-uniform in their captions when the plots earn it. And when a manager slips one encouraging sentence into a call, back them so it sticks. None of this asks for melodrama. It asks for alignment of measurements, calendars, and words with the star we actually met. Parker's loudest message isn't a single discovery, it's rhythm. Switchbacks in trains, heat in packets, microstreams echoing downstream, shear bands that won't sit still. A wind that co-rotates farther and faster than our comfortable models allow. A corona with a Helicity filter that decides which particles get cooked. That's the song. Our job is to get the tempo right, share it fast, and let operators hear the beat. If we do that, we trade surprise for timing. We stop flying crews through pulsed showers we could have dodged by 3 days. We stop losing small sets to stair steps we could have seen coming. We stop calling 5-day grinds unforeseen. We'll still get days that humble us, but the worst misses will be the ones we chose by keeping the verbs safe and the plots quiet. Say the sentence out loud. The sun isn't steady, it's rhythmic, and that rhythm is the lever we can pull. The quiet truth in the ask. The sun has a pulse, and pretending it doesn't is the real risk. If you want the unsoftened plots and the timing that actually helps, subscribe. Then watch our Parker Cadence watch list and the Neutrino listening windows we're tracking next. Those two together could settle the deeper question. New episodes weekly. Stay for the figures, not the spin.